the limit as x goes to infinity of the natural log of x over x squared. If x is getting really big, the natural log is also getting very large, so that's going to be infinity. Of course, if you take a very large number and square it, that also goes to infinity. So we have infinity over another infinity. This is an indeterminate form, and I can apply L'Hopital's rule by taking the derivative of each function separately. Here's where the algebra might trip you up a little bit. The natural log of x, that derivative is going to be 1 over x, and of course this derivative is 2x. But that's not really how I want to write this function down. So 1 over x all over 2x is the same thing as 1 over 2x squared. How do I get there? If it's not 100% clear to you that you can just pretty much put this guy in that guy's denominator to get the 2x squared, here's what's really happening. You know from your days as a 4th grade student that if you have, say, a fraction divided by another fraction, then what you're supposed to do is, well, dividing fractions is easy as pie. You flip the second and multiply. Now, you never saw fractions divided this way as a kid. You would have seen this problem written more like this. But you probably do know enough to know that 2/3 divided by 1/5 can be written this way as well. You also remember from your days of younger math that this can be 2/3 times this reciprocal, 5 over 1. Well, keeping that in mind, that would mean that basically these guys make the new denominator. So these make the new denominator, and these guys make the new numerator. So we get a 10 over 3, right? Well, I'm going to apply this similar idea here, but I don't quite have a fraction over a fraction. I have a 1 over x over a 2x. Well, that 2x as a fraction is 2x over 1. So applying the same idea, it's like it's this fraction divided by this fraction, or this multiplied by this guy's reciprocal, or these guys make, the product of these make the new denominator, and the product of these make the new numerator. You're going to see this enough times where that will become like second nature type of thing for you to do. But for now, I hope it's clear that if I had 1 over x over 2x, I would think of it as 2x over 1. That's my new numerator, 1. That's my new denominator, 2x squared. And as x goes to infinity, this gets gigantically huge, and 1 over gigantically huge is very, very tiny, so it goes to 0. So ultimately, that limit would approach 0. So the limit as x approaches infinity of natural log of x over x squared is going to equal 0.